All right, let's talk about Unit 3, Lesson 2, Problem Solving with Proportions. So, a proportion, just to review, is an equation. So you'll see an equals with two equal ratios. A ratio is just a fancy word for fraction. So, you'll see a numerator and denominator set equal to a numerator and a denominator. What you'll notice is there is not going to be addition to the left or right of the fraction. So, because we have two fractions equal to each other, if we had common denominators, that's why cross multiplying works. So we're going to take a times d, and that will have to be equal to b times c. All right, so let's look at the first example. If you can easily guess the missing value, you're welcome to go ahead and do that. If not, this strategy always works, and it's still pretty quick. We've got 6 times v equals 7 times 5. So simplify, we get 6v equals 35. Those are being multiplied, so we'll divide both sides by 6. Now, that does not go in evenly and it does not reduce, so you can leave your answer and it would be fully correct. If you want to get the decimal, you can go ahead and divide. It will be an approximate answer since our decimal does not terminate, and we use little squigglies, we get 5.83 repeating. But either answer would be acceptable. Let's look at example 2. We've got 10 times 4, and then we've got 5 times the quantity y minus 1. So you will need to distribute the 5 if you didn't use your parentheses. So y is already on the right, I'm going to add 5 to the left side. So 45 equals 5y, and then we will divide by 5. So y equals 9. All right, so we can use proportions when we are comparing two different quantities. So what we want to do is we want to find the corresponding sides, set a proportion, cross multiply to solve for the missing length, and then label our answer. I check my work by if my answer is supposed to get bigger, did it? If it was supposed to get smaller, did it? So let's look at the first example. You want to read through the problem and kind of see what two items are being compared. So I see francs and dollars. And notice I'm going to have the same problem and we're going to solve it two different ways just to show you there are multiple solution strategies. So the first way is I'm going to take francs and dollars. Francs and dollars. So I look at the last sentence and it says 6 francs is for $5. So I've got 6 francs compares to $5. He wants to exchange 48 francs for how many dollars? That's what we're looking for. I like to use the labels so I know I'm putting the numbers in the correct spot. So now if we solve, you've got 6 times x, and then 48 times 5. So we get 240. Divide both sides by 6. So we get 40, and we were looking for dollars. That's my label. And I should have had more, but less than the total, because we have less dollars for 6. So my answer seems reasonable. All right, let's talk about Paul. Let's find out what. Same idea, but now I'm going to do francs and compare it to dollars and dollars. So what I know is we've got 6 francs, and that's going to be the same as $5. Notice how I put them both on top. And then I've got 48 francs, and I want to compare that to an unknown amount of dollars. So my fractions are not quite the same. But we're still going to solve because it's a proportion. 6 times x equals 48 times 5, and you'll notice the work ends up being the same as the first problem. So our answer will be the same. So I find The left one is probably more comfortable for students, but you're welcome to do either strategy. All right, let's look at our last two examples. So, what are we talking about? We're talking about tall and wide, or height and width. So I'm going to do height and width. And you can set it up together. I'll show you a different way. So we know the original is 5.6 tall over 13.4 wide, and we want a height of 2.8, and we want the new width. So same idea. I've got 5.6x equals 2.8 times 13.4. So 5.6x equals 37.52. Divide both sides by 5.6. So we get 6.7, and we're talking about inches and the width. All right, the last problem is triangles. So I kind of think this is a height, and I think of this as a base. So same thing, I've got a height and I've got a base. So height over base equals height over base, if you like them separately. So 72 over 12 is equal to x over 18. So 12x equals 72 times 18. We get 1296. So divide both sides by 12, and we get 108 centimeters. And that is smaller than 18, and 72 is smaller than 108.